Okay, so just getting started. Rightio. So now for those of you watching on YouTube, we've just started the recording and Zane's chosen for us to do question 1, question 4. All right. So question 1 is asked you to calculate the domain and the range of the following functions. And I've given you a polynomial and a square root function. All right. So we'll do the polynomial first. And I might just put a divider. Hey Zane, just wondering, is that noise from the class next door distracting? Okay, that's cool. Alrighty. So remember that the domain. That's way too big. We'll cut it down to 24. The domain all x values and the range is all y values. All right. So we've got to work out what x values could we potentially plug into this polynomial. Are there any x values that we could not plug into this polynomial and get a real number? And then once we've done that, are there any y values that we cannot get? So first up, this is a bit of a garbage way of writing a polynomial, and I did that on purpose. So we're going to rewrite it. So y equals, and when you're running polynomials, it's a really good idea to negative x squared to do the highest degree first. I'll put spaces in. Okay, so you can see how that's the same as what I've got up there. It's just that I've put it from highest degree down to lowest. Oh, sorry. There, is that better? Sorry, I forgot to press the button where you follow me. Yeah, sorry about that, mate. Alrighty. So yeah, so I've written the formula, and this is the same function. It's just I've written the biggest term first. Now, what is the degree of what's the biggest degree? So is it to the power of 1, to the power of 2, to the power of 3? What's the largest degree? To 2. Thank you. All right. Now, is the coefficient A? So remember, A is the coefficient of the first term, or the biggest term. Is it positive or negative? Negative. Okay. So because the largest degree is even, we know that as x approaches infinity, y will approach infinity. As x approaches negative infinity, y will approach negative infinity. So we know that it's going to be a single curve. Now, because A is negative, we know it's going to be a curve like that. Okay? And I'll put in a little, two really terrible arrows showing that they go on. Okay, so because it's a polynomial, polynomials have a domain of negative infinity x to, okay. So because it's a polynomial, the domain goes from negative infinity to infinity. We know that any polynomial that you put in, you're going to get that. Now the issue is the range. So would you agree that, actually if I draw, would you agree that our polynomial, the range comes from negative infinity up, but it does not go beyond that point? So you can't, it doesn't matter what x value that you plug in, you're never going to get a y value up here, or here, or here, or here. Okay, because this point here, that is the maximum point. That's the maximum of the graph. It does not get more than that. Okay, so that's the maximum. Yeah, so our range is going to have an upper limit, and we need to figure out what that upper limit is. Now, how do we find out the turning point of a polynomial? You find the derivative, negative 2 plus 2. Okay, so since y is, why is there no equal sign there? There we go. Negative 2x plus 2. Okay, so if y equals negative x squared plus 2x take 1, then y dash is negative 2x plus 2. Okay, and then we want to figure out what y dash is, what x is when y dash equals 0. So if you work that out, you'll find that x equals 1. Now I've skipped a couple of steps to go from the 0 equals negative 2x plus 2 to x equals 1, but you get that? Or would you like me to go through those steps? So new. So, okay, so the first step would be to subtract 2 from both sides. And then we would divide both sides by 2, by negative 2, sorry. So we put it over here, subtracting 2. And here we are dividing by negative 2. See those 2 steps? Okay. So now we need to find out negative plus 2 times 1 take 1 equals 1 plus 2 take 1 f1 equals 2. See how that works? And actually, I need to the bracket should be over here. Hang on, should it? No. Sorry. I was right the first time. Yeah. So that should, -1. Zero. Sorry, that was my bad. Because the negative, this is actually a -1 here, which we never write. So that negative isn't getting squared. It's just the x. It's just the 1 getting squared, and then that's multiplied by -1. All right. So the turning point, or the max, is and if that is the case, the range less than or equal to 0. Now, does that make sense to you? Let me see you typing. Why wouldn't it be? Why wouldn't it be less? Why be less than? Yeah. So this here, the range equals -infinity. So y is greater than -infinity. That's what that bit means. And y is less than or equal to 0. So y can equal 0, or y can be less than 0 and go down to -infinity. All right. Cool, cool, cool. Okay, so the next one. Now this is a square root function. So some special things about square roots with real numbers. Now I don't know how to do a non-equal sign, so I'm just going to and then move it. Okay, there we go. So you can't. What I've written there is you can't have a square root of a negative number and it be real. So if you square root a negative number, you actually get an imaginary number, which we are not dealing with. You don't get imaginary numbers on the Cartesian plane. So what we're saying here is that therefore x plus 9 cannot be negative. Okay, so x plus 9 can't be negative. You get that? Cool, cool, cool. And also, I don't know how to write this mathematically, so I'm just going to write it in text. The square of a real number cannot be negative. Okay? So therefore, y So do those two things make sense to you based on your understanding of how square roots work? Cool, sweet. So that's basically all we need to know. Now, before the domain was easy, the range we had to do a bit of work. This time it's the range that's easy. The range, y has to be greater or equal to 0, and then goes up to infinity. Yep. Yep. Nothing particularly, God, these throws are annoying. Nothing particularly groundbreaking about that. So we want x plus 9 has to equal 0 or has to be equal to or greater than 0. Okay? So what is the smallest number that x can be for x plus 9 to equal 0? Yeah, because 0 plus 9 would equal 9. What we're after is negative 9 plus 9 will equal 0. Okay, so negative 9 is the smallest number that x can be. If x is negative 10, don't worry, mate. So if x is negative 10, then x plus 9 is going to be negative 1. We can't have that. And I'll put a nice big red stroke through that so that we keep in mind that we cannot have that. Okay? So therefore, the domain less than or equal to, Okay, so do you see how we use our understanding of polynomials and our understanding of square roots to logically solve that problem? All right. So would you be a little bit more confident in approaching questions like this in the future? Yeah, cool. Give me a second. I just need to plug in my laptop because it's about to die. And we'll move on to that question 4 shortly. All right. Cool. So my laptop's not going to turn off halfway through a lesson now, which is always a good thing. Alrighty. Go away. Alrighty. So now what we're going to do is question 4. So let's go over to that. Okay. So what I might try to do for this one I might try and do this. This might be the best way to organize it so that it's nice and easy to understand. And then no, I want this. 1, 2, 3, 4. And I might just move them a little bit. Okay. And then I want to draw lines like this. Now this, I may come unstuck here if I need to do a lot of working. But we'll cross that bridge when we come to it, I guess. Alright. So Zane, just confirming that you're there and you're ready to move on? Cool. Alright, so first thing we're going to do, and I will make a square so it's obvious what we're doing. First thing we'll do is question 1. Okay? So question 1 is -4 divided by x minus 2. Okay? So, with vertical asymptotes, a vertical asymptote occurs when y, or in this case fx, cannot be defined. Okay? Now there's one major way for creating this situation, and this is if we try and divide something by 0. Now if we try to divide something by 0, the answer is undefined because it's both positive and negative infinity at the same time, and it basically just breaks mathematics. So the vertical asymptote, so V, will occur when the denominator is 0, when x minus 2 equals 0. So, can we think of a number that x can be for x minus 2 to equal 0? 2, yep. So, vertical occurs at x equals 2. Done. Alright, so what I want to do is I want to find the vertical asymptotes for all 4 of these, and then we'll find the horizontal asymptotes for all 4. Okay? Because basically what's going to be is we're going to be doing the same thing over and over. Okay? So V is at 1 minus x equals 0. So what might x be? Yeah. So if the denominator equals 0, then fx is undefined, and therefore that is our vertical asymptote. So we want 1 minus x to be 0. So 1 minus what would be 0? 1 minus 1 is 0. So in this case, our vertical asymptote occurs at x equals 1. Now, our next two are a little bit more complicated, and that is by design. So this should look familiar. It's a quadratic, and to find out the what x has to be for the denominator to be 0, you have 2 choices. You can either do the quadratic formula, or you can factorize. So what I'm going to do, I'm going to factorize because I'm lazy. Okay? So let's think about what two numbers multiply by each other to give -6. We can have 1 negative. We have like plus 1 times -6. You could have 2 times -3. You could have -2 times 3, or we can have -1 times 6. Those are our 4 options, basically. And in this case, my x's are multiply symbols. This is not the best program for teaching mathematics, but it's what we've got until Monday. So those are our 4 options. Now, what we want is to choose one where if we add them together, we get the coefficient here. So what's the coefficient of the middle one? It is 1, because there's nothing there. So it's 1 times x. So if we add some of these numbers together, 1 plus -6 equals -5. No. 2 plus -3 equals -1. No. If that plus was a minus, that would be fine. -2 plus 3 equals 1. We found it. Okay? And this is a method which you guys kind of didn't want to do last term. I think it's a bit of an underrated method. And a lot of you guys were unhappy with it because it only works in certain situations. But for simple things like this, it can be really handy in doing things quickly. So, because we have -2 and 3, we know that x squared plus x minus 6 equals x take 2 times x plus 3. So we factorized out our denominator. And now we want to say, okay, we want that to be 0. So there's 2 possible values x can be. Yep, 2 and -3. Done. Okay? Sweet. So I'm just going to move this box up a bit because there we go. Another one. Come on. There we go. Alrighty. So now let's look at question 4. The denominator for question 4 is x squared minus 2x take 8. So we want all the numbers that multiply together to give -8. So similar to what we did before, 1 times -8, 2 times -4, -2 times 4, and -1 times 8. Okay? Cool. So what's the coefficient of the middle? It is -2. So we think, okay, so which combinations, when we add them together, will sum together to give -2? So 1 plus -8 equals -7. No. 2 plus -4 equals -2. Okay, so we're happy. We found our combination. So again, we can just write that. X plus 2, x take 4, and again, we want that to be 0. So we can potentially get 0 if x equals what? Yep, correct. Sweet. So you okay with that? All we're doing is we're making the denominator equal 0. No, it's not the same with the horizontal asymptote. So the horizontal asymptote, and I gave you guys, if you go back through the PowerPoint, I gave you guys a table of how you work out the horizontal asymptote. But I will write it here. So you're looking at the degree. So numerator degree, if that is less than the denominator degree, hang on. H equals 0. Okay. Let me just write the whole thing up and then all right. Okay. So what we're looking at is we're looking at the degree of the biggest degree in the numerator and the biggest degree in the denominator. Okay? So if the biggest degree in the numerator is less than the biggest degree in the denominator, then the horizontal asymptote must be at y equals 0. That's just how it is. Okay? So what we're going to do is we are going to write down the degree, the largest degree of the numerator and the largest degree of the denominator. So the largest degree of the numerator, well, the numerator is -4. Okay? So there is no x there. Okay? So basically it means that x has been made 1, which means that x is to the power of 0 in the numerator. Okay? Can you just let me know in the chat whether you get that x is to the power of 0 in the numerator? Because there is no x. Yep, you get it. And for the denominator, x is equal to, well, let's have a look at it. It's x minus 2, so x is to the power of 1. Okay? So currently the numerator degree is less than the denominator degree, therefore horizontal occurs at y equals 0. Okay? Okay. Cool. Now let's look at question 2. Okay, so the degree of x in the numerator, I hope I'm spelling numerator correctly, is x equals 1. Okay, because we have a -2x up here. Then we have the denominator. I'll put in a space there. The denominator is 1 minus x, so x is to the power of 1 again. Okay, so here we have the numerator degree equals the denominator degree. Now this is what we did in that lesson on horizontal asymptotes. So the horizontal asymptote occurs at a fraction of the coefficients of the two biggest degrees, of the biggest degree in the numerator divided by the biggest degree in the denominator. So the coefficient for the biggest degree in the numerator is -2. The coefficient for the biggest degree in the denominator is -1. So -2 divided by -1 is then 2. Therefore, h occurs at y equals 2. I'll just put in a couple of circles in red. So so it's obvious which coefficients I am referring to. Not necessarily just for you, but for anyone who's watching when I put this up on YouTube. There we go. So those two. Okay, so the numerator is -2, the denominator is -1. Why would the degree be -1 and not 1? Now the degree is 1, the coefficient for the denominator is -1 because it's 1 minus x. Okay, so you have to get used to the idea that there's an invisible 1 that we always have in here. Okay, and that's just something you need to get used to. Whenever you see a pronumeral, whether it be x, y, z, a, b, c, alpha, beta, gamma, whatever, and it's just on its own, just assume that there's a coefficient of 1 in front of it. Alrighty. Question 3. Now, what's the degree in the numerator? It's just an 8, so x to the power of 0. Denominator, x to the power of... Hang on a second. Boys, I'm doing a live session. Can you keep it down? Alright. So x to the power of, we have an x squared here, so x is to the power of 0 in the denominator. Alright, so the degree in the numerator is less than the degree in the denominator, therefore h occurs at y equals 0. What have I done there? There we go. The denominator is 2, yeah, because it's an x squared. Cool. And finally, the numerator here, x is to the power of 2, because we have 4x squared minus 6. And the denominator, x is also to the power of 2. Therefore, we need to look at the coefficients. A coefficient of 4 and a coefficient of 1. So 4 divided by 1, because we have a coefficient of 4 in at the biggest term, and a coefficient of 1 at the biggest term. So we make a fraction of those two. 4 divided by 1 is equal to 4. Therefore, the horizontal asymptote occurs at y equals 4. Okay. So that's the end of the lesson. How does that look for you? Makes it easier? Okay, cool. So all of Monday's lesson is going to be us going through answers, and I think we're going to be working in small groups just to try and get everyone up to speed. We'll see how we go. Anyway, thanks, Zane. So this is going to probably take about 14 years to upload onto YouTube, and we'll see how we go. I've copied down the work to reviser. Yeah. So hopefully, yeah, I'll save this and upload to YouTube ASAP, but it's going to be huge, so it's going to take forever. Anyway, mate, I'll see you at the Q&A on Friday, if you're free then. Otherwise, I'll see you in class on Monday. Sweet, cool. See you then, mate.